Hi and welcome in this new video. Hope you're doing well, hope your day is great, and stay because you are going to create a fully functional data pipeline that interacts with Snowflake and AWS to manipulate your data with the Astro SDK. My name is Mark Lomati, I'm the head of customer education at Astronomer, best-selling instructor on Udemy, and let me tell you what is the Astro SDK. Well, the Astro SDK is a Python SDK for rapid development of extract, transform and load workflows in Apache Airflow. It is the easiest and fastest way to get started writing DAGs. And if you used to write a lot of DAGs, guess what? The Astro SDK will dramatically increase your development speed. The Astro SDK is composed of a few classes and operators, I think like 8 operators, and it is built on top of Airflow. So as long as you have Airflow, you can use the Astro SDK. Now, at the end of this video, you will have built this data pipeline that loads a file from a S3 bucket into a Snowflake table. Then you will filter orders from that table. You will join two tables together with Snowflake. You will merge the table and you will transform the data to get an output and finally clean up the temporary tables. Trust me, that data pipeline is pretty amazing. That being said, this data pipeline comes from the Astro SDK documentation. So I strongly advise you to take a look at the Astro SDK documentation. You will find all you need from there. To follow the video and build that amazing data pipeline, you have two prerequisites. First, you need to have Docker installed on your computer, and I strongly recommend you to use the Astro CLI. If you don't know what is the Astro CLI, it is the easiest and fastest way to set up and run Airflow locally, and it is an open source project. You can still use the Docker Compose file of Airflow if you want to, but you will waste a little bit of time to get started with that video. To install the Astro CLI, go to the following page and follow the instructions. That's it. So now, if you are ready, fasten your seatbelt, take a deep breath, and let's go. The first step is to set up your Airflow environment, and for that you have the Astro CLI. Create a new folder like SDK, and in that folder, execute the command astro dev init in order to initialize your Airflow environment. As you can see on the left, you have new folders and files. For example, the folder DAGs to put your data pipelines, the folder include to put anything that are not data pipelines. You have the file packages.txt to add operating system dependencies, or requirements.txt to add Python dependencies, like the Astro SDK. So open that file and type the following line in order to install the Astro SDK with the providers Amazon and Snowflake, as you want to interact with those tools. Save the file, and now you can open the file .env. To run the Astro SDK, you need to configure the following environment variables. Do that in the .env file and then save the file. Finally, run your Airflow environment by typing the following command astro dev start. Wait a little bit until Airflow is up and running. Okay, after a few minutes, if you go on localhost 8080 and type admin, you should land on the following page. And now it's time to move to the second step. In the folder include, create a new folder data and a new file orders_data header.csv. Then make sure that you have the following data in it and save the file. By the way, you will find all the materials in the link in the description below. Next, we need to upload that file to a S3 bucket. So look for S3 and create a new bucket. Give a name to that bucket. In my case, markl-astro SDK. Don't use the same bucket name because it's not gonna work. You need to set a globally unique bucket name. Then you just scroll down and you click on create bucket. Click on the bucket and click on upload, then add files and pick your file in the folder include data orders data header. Click on upload. As you can see, the file has been successfully uploaded. If you click on it, you can see the path to that file in your S3 bucket as shown right there. This is pretty important. That's what we're going to use later in the video. Back to our console, as we are going to access that file in the S3 bucket from your data pipeline, we need to create an AWS access key. Look for IAM and click on it. On the left, select users, add users with the username Astro SDK, and you check access key programmatic access. Next permissions, select attach existing policies directly and check administrator access. Obviously, this is not recommended. You should stick with the S3 policy, but just for the example, we're gonna stick with the administrator access. Click on next tags, then next review and create user. Now it is extremely important that you keep the access key ID and the secret access key somewhere safe on your computer because you won't be able to access your key anymore. So download the .csv file and now you can click on close. Okay, at this point you have successfully uploaded the file to S3 bucket. You have created a new user with the access key that you will need to interact with S3 from your data pipelines. Now it's time to move to the third step, which is configuring Snowflake. On Snowflake, make sure that you have an account admin and click on worksheet. First, we create a new database, Astro SDK DB, execute that command. As you can see, the DB has been successfully created. You can refresh on the left to see the new DB, Astro SDK DB. Make sure that it is selected as shown right there. And now you can execute the following two commands to create a warehouse and a schema. Execute the following SQL commands, and you have successfully created the warehouse and the schema in the DB. Next we want to create and populate two tables that we are going to use in our data pipeline. The first one is customers table that we will join with an orders table that we will create with the Astro SDK. Make sure that you have selected the Astro SDK schema and use the following SQL request to create the customers table. Execute it. As you can see, the table has been successfully created. Next, use the following SQL request to populate the table. And we have 3 rows in the table. Now we need to create the second table, the reporting table. For that, use the following SQL requests, execute it, and populate the table with the following SQL requests. After a few seconds, you should see that 3 rows have been inserted in the table. Okay, we are done with Snowflake. If you want to take a look at those tables, you can do it just by clicking here. Then you go to your data, you select your database, the Astro SDK DB, then the schema and the tables, and you can see the 2 tables, customers table and reporting table. If you want to see the data that you have in it, you can click on data preview and you will see the data that you just inserted. Okay, nothing too hard here. I mean, we have a table, reporting table with the customer ID, customer name, order ID, purchase date, and so on. And we have another table, customer table, with again, customer ID, customer name, and type. Now it's time to move to the 4th step, which is to create the data pipeline. Back to Airflow, since the data pipeline interacts with Snowflake and AWS, you need to create the corresponding connections. For that, you go to Admin and Connections, click on the following button to add a new connection, and the first one is AWS default. So AWS default, the connection type is Amazon S3. Then at the bottom in the extra parameter, you need to specify your access key. Type 2 double quotes, AWS access key ID with your access key ID that you can find from the CSV file that you downloaded before. Copy that value. Obviously, your access key ID will be different than mine. And add the AWS secret access key with your secret key, like that. Click on test to verify that your connection works, and you should see the following message. Then click on save, and you have successfully created your first connection to AWS. Now it's time to create another connection. So go back to admin and connections for Snowflake. So add a new connection. And this time the connection ID is Snowflake _ default. The connection type is Snowflake. The host is the link to your Snowflake account. So go back to Snowflake and then at the bottom, click on your account here and copy account URL. Copy it and paste it there. Next, you need to specify the schema, which is Astro SDK schema. Then you need to put your username and your password. Just below the account name is what you can see here. The warehouse is Astro SDK DW. The database is Astro SDK DB. The region is what you have here. The role is account admin. And that's it. Now you can click on test to check your connection. And as you can see, it works. Last step, just click on save to save your connection and you have successfully created the AWS and Snowflake connections. Let me give you a quick reminder of the data pipeline that you are going to create. First, you are going to load the file that you have uploaded in the S3 bucket into a table. Next, you are going to filter the orders from that table and you will join the orders with the customers. Next, you will merge the data into the reporting table to finally transform the data from the reporting table in order to get the purchase dates. And finally, you are going to clean all the temporary tables that will be created along the way. So if you are ready, let's go. Back to your code editor, in the folder DAGs, create a new file astro orders.py and make the following imports. First, datetime. You need it in order to define the start date. Just below, you import the DAG object. Then you import the data frame from pandas, as we are going to transform data from a table. Then we need to import a special decorator, which is Astro import SQL as AQL. So what is AQL? The AQL decorators allow running both SQL and Python operations within a Pythonic context. For example, you will be able to execute both SQL requests or Python functions with those decorators. And what does it mean exactly? Well, it means that you will have access to the Astro SDK operators such as append, cleanup, data frame, transform, and so on to manipulate tables, data, and SQL at ease. Just below, import the file object and import the table object. As we are going to interact with files and tables. Next, we define variables that contain the file, the tables, and the connections we are going to interact with in our data pipeline, so it will be easier to manipulate them. So first, create the following variable with the path to your file in the S3 bucket, and you can find this path just by looking at the URI as shown right there on your file. Next, you define the connection ID of your AWS account. Same thing for the Snowflake account. Then you define the table names that we are going to interact with. So the orders table, the filtered table, the joined table, the customers table, and finally the reporting table. Okay, we have the tables, we have the connections and the file as well as the imports. It's time to define the DAG object. So type with DAG. The DAG ID is Astro orders. The start date is datetime, the 1st of January 2022, with the schedule parameter, daily, and the catch-up with false. And now we are ready to define the tasks. For the first task, we want to extract the data from the file in the S3 bucket into a table. And for that, it is very simple as we use the Astro SDK. Let me show you this. You create a new variable orders data and you call the method aql.loadFile. LoadFile allows you to transfer data from a file into a table easily, just by specifying the path to that file and the table where you want to put the data. So first, you specify the input file parameter with a file object, as it is a file, and the path to that file. Since that file is within the S3 bucket, you need to specify the connection ID, S3 connection ID. Then you need to specify the output table parameter with the table object, as it is a table where you want to put your data. And you just indicate the connection ID with the Snowflake connection ID. No need to specify a name here. Why? Because you just want to create a temporary table where the data will be stored, as we are going to move them again just after that task. Remember, when you define a table without a name, that means it is a temporary table. And this is very useful when you want to store data, but you don't want to keep that data when your DAG is completed. And that's exactly what we want to do here with the orders. Next, it's time to implement the transform tasks. We create a new table object, customers table, as we want to interact with that table in Snowflake from our data pipeline. We specify the name Snowflake customers, so it is the customers table, and the connection ID, Snowflake connection ID. Again, by doing that, we are able to manipulate to interact with the customers table in Snowflake from the data pipeline. By the way, don't forget to remove the file name from that path. Otherwise, it's not going to work as you already add the file name here. Next, we need to create the functions to transform the data. This is where the transform operator or the transform decorator steps in. Indeed, the transform operator allows you to transform your data. It implements the T of an ELT system by running SQL queries. Each time the pipeline does a transformation, that creates a new table from the select statement that you can pass to other tasks easily. Exactly as you will do with XComs, but since you use the Astro SDK, you don't have to take care of that. The first transformation that we want to make is to filter the orders that are above 150. So let's do that. We use the AQL transform decorator, then we define the Python function filter orders just below. We need to pass an input table that will be the orders data table that we got from the AQL load file method. And finally, we execute the following SQL request where we check if the amount is above 150. And that's it. That task returns a new table with the filtered order. The second transformation that we want to make is a join between two tables. Between the table that we get from the task filter orders, so the filtered orders, and the customers table that we have already created with data in Snowflake. So let's do that. Just below, you use the AQL transform decorator again. Then join order customers, that's the new task. You pass two parameters, filtered order table and customers table, as you want to join those two tables. And you use the following SQL statement. I'm not gonna go over it, but basically it is a join between two tables. At this point, you have successfully created two tasks to transform your data in your Snowflake table. And as you can see, since we use the Astro SDK, it is very straightforward. You don't have to manipulate the Snowflake hook operator to interact with Snowflake and specify multiple times the connections and so on. Nothing like that. You just need to use one decorator, the table that you want to interact with, and the SQL request. It is as simple as that. Finally, we can specify the dependencies. So we want to get the joined data. That will be a temporary table. And we want to execute join orders customers with the filtered orders. So we pass the orders data to filter orders and the customers table to join orders customers. That's it. We are able to load data from a S3 bucket into a table. Then we are able to transform data in those tables and join them. Now we want to merge the joined data with the reporting table. Let's do that. The merge operator allows you to add data to an existing table with conflict resolution technique like ignore and update. And that's what we're going to use right now. So create a new variable, reporting table. Remember that we have already created with data the reporting table in Snowflake, and we use the AQL.merge operator. We pass the target table with the table object. It expects the name of the table, so reporting table, as defined in Snowflake reporting, and the connection ID, Snowflake connection ID. Then we need to specify the source table, joined data, that we create just before with the join orders customers task. To do the merge, we use the order ID column, and if there is a conflict either with the customer ID or the customer name columns, we want to use the data from the joined table. Now we have implemented the merge task to merge the two tables, joined data and reporting table. The last transformation that we want to make is to transform the data from reporting table into a data frame. Let me show you how to do that. Just before your DAG object, create a new task with the AQL.dataFrame decorator. What does it mean? Well, with that decorator, you are able to transform SQL table into data frames so you can manipulate that data frame in a Python environment with pandas. Just under the decorator, you specify the task, transform data frame, you pass a data frame, and now you do your transformations. So in that case, we want to keep the column purchase date, we want to print the dates, and finally we want to return those dates. Again, the power of that operator is that you can manipulate your data, you can transform your data by using pandas and not SQL requests as before. But be careful, because when you transform your SQL table into a data frame, you are putting all the data from that SQL table into your Airflow environment. So if it is a big table, you may end up with memory issues. That being said, we need to call the task with the reporting table. So at the bottom, just after the merge, type purchase dates equals to transform data frame, and you pass the reporting table that you create just before with the merge. Finally, the last task that we want to add to our data pipeline is to clean up the temporary tables that we have created when we use table without specifying the name. So just after purchase dates, you type purchase dates again, you specify the bitshift operator to indicate a dependency, and you use AQL cleanup. Like that. And that's it. You save the file and you have successfully created your data pipeline. On the Airflow UI, you should see the DAG Astro orders. Click on it and go to graph, and you should obtain the same data pipeline as shown right there with the tasks load file, filter orders, join orders, customers, merge, transform data frame, and cleanup. Now it's time to trigger the DAG by turning on the toggle right there. Refresh the page. And let's wait a little bit until the data pipeline is done. As you can see, the file from the S3 bucket has been successfully loaded into a temporary table. Then the orders have been filtered. The join between the two tables has been successfully completed. Let's wait for the transform data frame. And as you can see, we end up with a failure. Why? Well, click on the task and go to the log. If you scroll down, you can see the following message telling you that this task has failed because you do not have a custom XCOM backend setup. And why? Well, because as I told you, since you transform the SQL table into a data frame, you are pulling all the data from the table into your Airflow environment. And if you don't have enough resources to handle your data frame, you will end up with a memory overflow error. So that's why you have this warning. It's not really like a failure per se, but it's more like a warning that you must have a XCOM backend setup to use that functionality. But just above, you can see the output of all tasks that have been done before with the purchase dates. That means you have successfully loaded the S3 file into a table, joined the tables, merged the tables, transform the tables. Now, just to make sure that the temporary tables are cleaned up, you can go back to your DAG, then click on the task, and let's mark the task as success. Okay, and now cleanup runs as expected. After a few seconds, you can see that cleanup has been successfully completed. So well done, congratulations, you have created a fully functional data pipeline that interacts with AWS and Snowflake using the Astro SDK. You are able to transform, load, merge, join your tables and your data just by using very simple operators or decorators, and that's the easiest and the fastest way to do it in Airflow. That example comes from the Astro SDK documentation, so please take a look at it. Don't forget to smash the like button and subscribe to my channel if you want to have more videos like that. I wish you a wonderful day, take care, and see you soon.